Hello, good evening everybody. My name is Vishvadeep and I welcome you all on Unacademy Computer Science Channel. In this particular lecture, I am going to talk about graph data structure and more specifically on the depth first search traversal of the graph, how DFS is done, how DFS is actually implemented using stack, and based on DFS some questions I have brought. So those things we are going to discuss in this particular lecture, which is the GATE computer science series lecture of data structure. So without any delay, let's start the session. Before I go forward, let me introduce myself. My name is Vishvadeep and I work as a team leader in computer science department in Unacademy branch team. I have written the GATE exam multiple times. This is my rank 19. I have few more ranks: 19, 119, 440, 682. Went for my masters to IIC Bangalore, another masters from BITS Pilani, a rich experience in teaching. These are the courses I am dealing with on Unacademy's platform. If you guys are learning from Unacademy's YouTube channel, then you should have one more option. You should opt one more option from Unacademy's side, which is the free special classes, quizzes and test series from Unacademy's platform. So if you are unaware of that particular thing, then do one thing: go to unacademy.com or download the Unacademy Learner app. Go to my profile and check out the special classes. To unlock the special free classes, you will need a particular code, and this code is this. The code needed is this: VDeep10. If you use this particular code, you will unlock free content of Unacademy's site. What are the free contents? Special classes. Then apart from that, second thing, you'll be getting quizzes, you'll be getting free test series, and lots of other options are there which are absolutely free on the Unacademy's platform. So go and check it out. Follow my profile so that you can get the notification of all my free classes which I'm going to conduct live. Like tomorrow I'm having two classes. One is 12 p.m. Another one is 3:30 p.m. So if you want to attend these two classes, then join unacademy.com or Unacademy Learners app. This particular 12 p.m. class will be on the COA PYQ, but those PYQ are not normal one. Only tough PYQ I have chosen so that I can explain how you will solve those tough questions. And this one will be your guidance. 3:30 p.m. class is for guidance, how exactly you will improve your marks in GATE in the test series. So many students are querying, sir, marks kam aa rahe hain, this is the problem, that is the problem. I will listen the problem, you will get the answer. 3:30 p.m. remember, tomorrow a strategy session, a planning session. I will listen your queries, I will give you the answer. If you guys want to revise this particular course, data structure, then the revision, free special class revision I am going to start on Unacademy's platform, again absolutely free. That is called as Roadmap to Master DS, and that particular series is starting from 3 p.m. onwards on 21st December. 21st December onwards, 3 p.m. daily, we will be having classes for revision Roadmap to Master DS. For GATE, we will start with the highest weightage topic, which is tree, and then further we will be having so many sessions on that. If you want to have the free test series, we have the free test series also for you. Enroll, enjoy the quality learning. If you guys are waiting for something to happen, it's not gonna happen. You need to make it happen. If you want to have the best quality learning in the best possible manner, then we have from Unacademy side an opportunity for you to learn in the best possible manner, and that is Unacademy Plus subscription. This particular subscription comes as live classes you will be getting. Those live classes will be very interactive. That's my personal experience. That kind of interaction, if you'll be having more doubts, more queries you'll be asking about a particular topic, more clarity you get about each and every topic. Hence it works towards your problem solving ability. If you miss any live class, definitely you can listen those classes in recorded mode too. you'll be having so many doubt solving, you'll be having so many practice questions, DPP and all, you'll be having so many weekly tests and so many other tests also, so that your preparation will be all around perfect for your gate. If you want to take Unacademy Plus subscription, it is available in 1 month, 3 months, 6 months, 12, 18 and 24. If you are targeting gate 22 or 23, then take the subscription as soon as possible, just because in this particular week only 3 new courses started. Algorithm starting from tomorrow, 18th of December. My course, which is COA, starting from 18th of December, and TOC, which is started just today only, 17th of December. So if you want to cover these courses, you can cover these courses for gate 21 also, gate 22 also, and you can enjoy the best possible learning in these courses. If you want to take the subscription, then one thing which you need to do is this: apply a code so that you can get the subscription amount less by 10% minimum. So if you want to have discount of minimum 10%, use this code VDEEP10 and you will be getting minimum 10% discount. But this code is not only for discount. If you use this particular code, you will get definitely a discount. Then you will be getting my mentorship. The person who has written GATE exam multiple times and cracked it multiple times with really good rank. Third thing, a person with a team which is preparing or which will give you the preparation of entire GATE preparation subjects. So there is a team, that particular team is putting the efforts a lot on your particular preparation. Connect your preparation with this team if you use this particular code VDEEP10. Remember, code VDEEP10 used for multiple things. If you are not a good person who can plan the things, then you should go for Iconic subscription. In Iconic subscription, your headache will be even less. Why? Just because you will be getting a personal coach from Unacademy side. That fellow will be an expert, and that expert will give you preparation strategy based on your personality and character. You will be getting study planner so that you can get the customized plan. You will be getting proper day-to-day activity planning. Apart from that, your performance tracking also. You will be getting study booster session, personalized test analysis so that you can improve your test marks, and preparation material also, including the practice sets and specialized notes. This Iconic subscription has all the benefits of Unacademy Plus. Apart from that, this personal coach and tracking of your performance facility. And this Iconic subscription also you can get discount if you use the code VDEEP10. This particular code, if you will be using, you will be definitely getting discount. You will be connecting your preparation to my team. You will be getting my mentorship. Apart from that, if you want your preparation to be iconic, use the subscription, get the subscription and have your rank iconic. The prices here mentioned are after the discount. Check out these prices. These are after the discount. Use the code, get the discount, enjoy the subscription in the discounted mode. This is the plus batches. You can see here computer science. So many top educators are there on this particular platform of the country. All these are teaching you on this particular platform. You can see these are the batches taken by top educators of country. And as I told, this is my course which is going to start tomorrow, a booster course which will boost your confidence and understanding and knowledge about computer organization and architecture, which is gonna be almost 10 to 12 marks in the GATE exam. So take the course, take the subscription of 1 month. In 1 month, you will be able to cover most of the courses, including this one, and you will enjoy lot. Today, we are going to talk about DFS, but before that, I need your energy. I need your energy, boss. If you are ready, let me know you are ready, and then we will start the session. If you are ready, let me know. Yesterday, what we did, we have seen graph, how a graph is represented in the adjacency matrix, then linked representation, then hybrid representation. After that, we have gone for BFS and how BFS is implemented using Q. This I already done. Now, next thing is we are going to start DFS. So depth first search done. Now depth first search we are going to do depth first search. Okay, now one particular point I want to tell you. If you are gate 21 person, then do one thing, don't go for BFS. For your preparation means for your courses, अब जितना हो चुका है उससे ज्यादा नहीं पढ़ना. Now whatever you have understood in different subjects, keep their deep analysis, keep their deep knowledge, and use that particular knowledge to solve the questions. I'm not talking about data structure, I'm talking about your gate preparation. So go for DFS, whatever the topic you have done for those. Don't expand your knowledge more in new courses more now. Okay, next, let's say depth first search. Before we start depth first search, I have a story for you guys. हाँ सर, कहानी सुनाओ. नानी दादी की कहानी नहीं है ना, तो ज्यादा एक्साइटेड होने की जरूरत नहीं है. बट इट्स अ स्टोरी विद विच आई विल ट्राई टू एक्सप्लेन यू DFS एंड डेफिनेटली यू विल अंडरस्टैंड इट प्रॉपरली. सो let's say we have a particular movie. That movie got released. That movie is so big. I am talking about normal scenarios when the theaters are open and you can go and watch the movies in the theaters. Normal scenario. So there is a movie got released. So big movie. Everybody wants to watch that movie. But you are not able to watch it. Why? Just because initially in the first 2-4 days, all the tickets are sold out. And whatever the available, those are so costly that you don't want to pay that much. See, I'm not saying you can't pay. You can pay, but you don't want to pay 1,000 rupees for one ticket for one movie. आप उस मूवी को देखना चाहते हो बट देखना नहीं जा पा रहे हो. क्यों? Just because you don't want to spend that much money. So you'll be waiting for what? थोड़े दिनों बाद, when maximum number of people will be able to see that, then we will go for that, right? Fine. Now let's suppose one of your best friend or one of the classmate of yours got a DVD print of that movie in a DVD. So there is a DVD or let's say Blu-ray disc. In that particular disc, that fellow got the movie high ultra HD print. But the problem is that fellow cannot forward that movie to you, means that fellow cannot make the copy of that movie. Only it is a DVD. So what we will do? The person who had that movie, that fellow will watch the movie, and after that, that fellow will pass the DVD to other fellow. Fellow will pass the DVD to best friend, one of his or her best friend. Suppose the movie was initially with a person A. From there, it has gone to person B, who is the best friend of that. किसको दोगे आप DVD? अपने best friend को. Now that fellow has DVD. Second person will watch the DVD and that fellow will give the DVD to his or her best friend. One of the best friend. Maybe you may have 2 or 3 best friend, but one of the best friend, just because only one DVD you have, you cannot copy it. Now the DVD has reached to the third person. The third person will watch the movie and will forward the DVD to another fellow. Then from there, that fellow will watch the movie and will pass on to the next best friend. Suppose it has reached, the DVD has reached to a person, let's say X, and that person is not having any best friend. See, not having best friend who not yet watched the movie. Everybody in his best friend's circle, everybody has watched the movie. So what that fellow will do? That fellow will return the DVD back to from wherever that DVD has come. जिसने भी उसको DVD दी थी, वापस उसको दे देगा. Now that fellow again will search, do I have any best friend remaining who has not yet watched the movie? If yes, then I will forward that particular DVD to that fellow. If not, then no. If you understood that concept, then the exactly same concept is applied for DFS. For DFS, we should have one source. That source who will originally have that DVD. So let's assume for the given question and given graph, the source is A. Source is A. Fine. A is source. Now A is having two best friends. First of all, A will watch the movie. Yes. And after that, A is having two best friends. What are the best friends of A? Best friend is nothing but what are the directly connected vertices from A. What are the neighbors of A? Can you tell me what are the neighbors of A? What are the neighbors of A? B and C. So if B and C are the neighbors of A, first of all, any of these two should be given the DVD. B या C में से कोई एक को DVD देंगे. To whom should I give the DVD? Let's say I have given the DVD to B. So B will be watching the movie. Now from B, B will search how many best friends I have. A, D and E. Among those, A already watched the movie? Yes. D and E is still remaining? Yes. Only two people have watched the movie, A and B. D and E remaining? Now among those two, one fellow will get the DVD. One fellow will get the DVD. Let's say B has given the DVD to E, means E will watch the movie. After that, from E, again E will check. E is done. Yes, E will check how many best friends I am having. B, C, D, F. Means direct neighbors of E. B, C, D and F. Now among those who have watched the movie B. So B, to B, E will not send the DVD. To whom E will send the DVD? Either C or D or F. The three fellows not yet visited, not yet watched the movie. So E can send its DVD to either C or D or F. Let's say we have given the DVD to C. Fine. Now C has been traversed. Watch the movie, traverse. Now C will find out its neighbor. C's neighbors are A and E. A and E. Now you tell me, is there any neighbor of C who has not yet watched the movie? Any neighbor of C not yet watched the movie? No. A and E both have watched the movie. Yes. So what C will do? मेरा तो कोई बेस्ट फ्रेंड है नहीं, कोई बात नहीं. E तुमसे हमने DVD लिया था, तुम ही रख लो, तुम और बेस्ट फ्रेंड ढूंढ लो. C is not having any best friend, so C will return its DVD to E. You only find if you have any other neighbor, any other best friend to give the DVD. So E means we will come back to E and we will try again that is there any neighbor of E remaining which is not yet traversed? Yes, D and F. So you can traverse only one of them. Which one you will traverse? Let's say you are traversing D. Then you have gone to D, means DVD has come to D. Now from D, one last step. What is the step? What is the unvisited neighbor of D? F. So F will be traversed. Fine. Now F will do what? Is there any neighbor of F? No. DVD will go back to D. Is there any neighbor of D remaining? No. Go back to E. E को DVD कहाँ से आई थी? From B, and then from B to A. Done. My execution done. This is one of my DFS sequence. Now you will ask a simple question. Okay, before you ask, I will only ask from your end. Ki sir, is it possible to have multiple DFS sequences of a given graph for a single source also? Yes. Yes, I can prove that. I can prove that. Instead of going with initially B, I can go from A to C. Yes. A, C, then E, then B, D, F. This is one of the correct BFS sequence. Now I am writing some sequences. You need to tell me correct DFS sequences or not. Correct DFS sequences or not, you just tell me. Okay? Fine, so I am writing these sequences one by one. You need to just verify that these sequences are correct or not. First one. One by one, you just check. So for all four, you need to tell me first one is valid or not, second one is valid or not, third one is valid or not, fourth one is valid or not. One by one you check and let me know so that I can understand you are learning. Your learning is utmost important for me. That's why in every single class I always stop my class with saying happy learning. ओके दो बार एफ लिख दिया है तो दो बार एफ को एक बार कर देते हैं. E and F it is. A, C, E, F, B, D it is. First one, A, its neighbor C, yes, its neighbor E, yes, E's neighbor D, D's neighbor B. Is there a neighbor of B remaining? No. Come back to D and F. Fine, first one is correct. Second one, A, C, E, F. A, C, E, F. F का neighbor D, next should be D, but they have traversed B. Wrong. A, B, D, E. A, B, D, E. Fine. Then C. Fine. There is no any neighbor of C remaining. Come back to E. Then F. Yes, correct. Fourth one, A, B, D, E. A, B, D, E. Fine. F. Fine. There is no any neighbor of F remaining. Come back to E and then C. Correct. So 1, 3 and 4 are correct. Second is wrong. Yes, good, good, good. Superb, superb. So many members given the correct answer. Amazing. Amazing, amazing. All the members who have joined us little late, if you don't know that we have free classes on Unacademy's platform also, then do that. Download the Unacademy Learner app or go to unacademy.com. Follow my profile over there. You will get lots of special classes. To unlock the free content and special classes, you need to use a code VDEEP10 so that you can get all the free classes. Okay, come back and let's solve this particular question. Now I will solve the question, but before that you will have to solve this question for me. Identify valid or invalid DFS sequence. First of all, A. Fine, it's neighbor B. Fine, then neighbor E. Fine, neighbor H. Fine, H ka neighbor F. F neighbor O. After F traversed G. Wrong. Why? Just because after F we have one particular neighbor remaining C which is not yet traversed. So after F we should traverse C. That is wrong thing. That is wrong thing. Got it? Got it? Next. Okay, there is a query. BFS and DFS की complexity बता देना. Samin, definitely we will discuss about that. एक और query है, when will the batch of GATE CSE 22 start? Okay, you are talking about 22 on YouTube or on Unacademy Plus. If you are talking about on Unacademy Plus, then we are having a special week starting from 20th of December in which we are going to talk about a very special plan for GATE 22 and 23. Free special classes on Unacademy to explain you that in GATE Computer Science and IT, what kind of subjects are involved, what are the important topics, what are the topics which you will have to learn and how you will have to learn, introduction of each and every subject by the top educators, including my courses are also there. So I will discuss in those two special classes how exactly you are going to plan your GATE 22 and 23. All these are free special classes. Fine. Okay. Chaliye. Second one, ACFH. ACFH. Fine. Then G. Okay. There is no any neighbor of G remaining. C already done. So from G we will go back H, and then from H, E, then B, then D. Yes, second looks correct. Third one, ABEH. ABEH. Then D. After D, there is no any neighbor of D. Yes, go back to H. Any neighbor of H next? Yes, F and G. So they are traversing F. After F, neighbor of F is C. Then G's third one is correct. Next one, fourth one, ACF. ACFH. H ka neighbor E. EBD. Fine. There is no any neighbor of D which is not yet traversed, already traversed. So go back to BEH and one node is remaining here which is G. Fourth one is also correct. Fourth one is also correct. So first one is invalid. Why? Just because after F we had to traverse C here, but they have given G. Wrong. Otherwise, remaining three are correct. I hope you got it. Great. Even Sakshi has given a dab sim like this. Check. Next one. A GPK. This is the question for your homework. It's a homework. If you are not aware of my term GPK, it's a very simple term called as Ghar Pe Karo problem. So it's a practice question. You can just check out. These are the 7 valid invalid questions. You just check out whichever is correct, whichever is not. You can give the answer easily. Now next question is based on the particular recursion. So if you know that the depth first search algorithm is a recursive algorithm, then you can solve this question. So what I would like to do, I would wait for this question to solve. First, I will explain you that how DFS is implemented using stack. Once you will understand this, then after that I will come back to that question and I will explain you that what is the meaning of the question, how to interpret the question, and then how to approach the question. It will be easier for all of you. So let's first do this particular thing, that how to implement depth first search using stack. This is the algorithm. As always, algorithm समझ में नहीं आती जब तक implementation नहीं होगा. Right? Okay, fine. Look at this. DFS you have called for source U. Then what you need to do? You need to mark that source as visited as soon as you call that function DFS. And after that, you need to find a neighbor V. Such neighbor of U which is V, which is unvisited. If you find any neighbor V of U which is unvisited, not visited, then call DFS function for V recursively. नहीं समझा? सर स्टैक कहां है? Recursion में है. You know that recursion cannot be implemented using without stack. Yes? Yes? Okay. Now let me take a simple example and I will explain you that how exactly this stack comes into the picture. This is the particular thing which you need to understand with utmost attention. Otherwise, दिमाग में नहीं जाने वाला. Okay. So let me take this particular graph, which is one of my favorite. Since years I am using the same graph for my explanation of BFS and DFS. Yes, I don't look too older, but yes, I am having a good experience of almost 13 years of teaching. Source A. Fine. Now let's do this particular thing. You have called for a DFS. Mark it as visited. I have marked it as visited. Visited means actually I have visited A. So in my traversing sequence, A I have visited. Now what? For A, I need to find one neighbor which is not yet visited. Is there any neighbor of A which is not yet visited? Can you type down in the comment box? Is there any neighbor of A which is not yet visited? Yes. Which one? B and C. So among those two, you need to pick one. You need to first pick one and you need to call for that. So you have checked, suppose for B, you have checked for B, you have called DFS function for B. But the thing is, when you are calling DFS function for B, when you are calling DFS function for B, then after DFS function execution of B, where you should return? Where you should return? B का DFS फंक्शन जब कंप्लीट हो जाएगा एग्जीक्यूशन में, आफ्टर दैट आप कहां रिटर्न करेंगे? योर आंसर इज टू A. So how should you track that I should return back to A? How should you do that? For that, look at this. I should use a stack. Internally, one particular stack will be used. Main में तो तब जाओगे ना जब आप DFS ऑफ A कंप्लीट करोगे, अभी DFS ऑफ B कंप्लीट होने के बाद A पे जाओगे. So what you will do when you have called from A to B, the DFS, ये देखो algorithm, I have found a neighbor V which is capital B of source A, not visited, yes, then you have called the DFS for that B. When you have called DFS for B, I'll have to push capital A onto the stack so that I can return it back. So that I can return back to A. Yes. Now what exactly I am doing is I am executing DFS for B. So I am just writing here initially executing DFS function for node A. After that you have called for B. So right now I am inside call for DFS function of node B. What is there? Mark it as visited. So mark it as visited means you have traversed B in the next sequence. After that you need to find the neighbor of B which is not yet visited. Neighbor of B not yet visited, we have D and E. Let's say we have called for E. But when the call for E will be completed, where should I go back? जब E का पूरा DFS function complete हो जाएगा, where should I go back? To B. From where only I am calling for E. So when you will go back to B. How will you go back to B? कैसे जाओगे वापस? So for that you need to push B onto the stack. Hope you are understanding. So when you have called for E, so DFS function now I am executing for E. As soon as you have called for E, I have pushed B onto the stack. Good Sakshi, good Jyoti, good Kiran, nice, amazing. Now I am executing DFS function for E. When I am executing DFS function for E means E will be marked as visited. Then I have traversed E in the sequence next. E is traversed next. Now next is what? I'll have to find out the neighbors of E which are not yet traversed. Neighbors of E, B traversed, C, D, F not traversed. Among these three, for one I'll have to choose either D or F or C. For one I'll have to call DFS function. Let's assume I have called for C. I have called for C. So when I have called for C, what should I do when I will call for C? I'll have to push E onto the stack so that I can understand once the call for C will be done, I will go back to E. So when the call for C is done, after that I'll have to go back to E. That's why I have pushed E onto the stack. Let's call for C means now I am executing DFS function for C. DFS function for C, if I am executing first statement, mark it as visited means you have explored the node. After that, you need to find out the neighbors of C not yet visited. Neighbor of C A visited, yes. Neighbor of C E visited, yes. Is there any neighbor? No. If there is no any neighbor, this particular while loop completes. No any DFS function call. If no any DFS function call means this DFS for C completed. Yes, completed. Yes, completed. So we will go back. Where we will go back? We will pop out E from here and we will go back to E. वापस E पे गए. DVD वापस E पे आ गई. Now what? Now again for E we will execute this loop itself. Is there any neighbor of E remaining which is not yet traversed? Is there any neighbor of E remaining which is not yet traversed? Yes, D and F. Now for either D or F you call. Let's say I have called for D. So when you have called for D, then E will be pushed back again to the stack. And let's call for D. Execution is now for D. Execution is now for D. When you are executing for D, what we will do? D will be explored means in the DFS sequence D is written and now marked as visited, and now find out the neighbor of D which is not yet visited. Is there any neighbor of D not yet visited? Yes. Which one? F. Call for F. when you call for f इस d का क्या करें इस d का हवन करें. So d will be pushed onto the stack so that once this f will be completed, function call of f will be completed, we will go to d, right? So d will be pushed onto the stack and we will call for f. When we call for f will be explored, marked as visited. Now find out neighbor of f not yet visited. Neighbor of f, d and e visited, yes, means f का execution done, no any neighbor, no any DFS call. Go back means d will be popped out from here and we will try to execute and try to find is there any neighbor of d, no any neighbor of d. Go back to then e. Is there any neighbor of e not yet visited? No. Then go back to b. Is there any neighbor of b? No. Go back to a. Is there any neighbor of a? No. Source का DFS function completed. Means I have gone back wherever I have called DFS source. Now what kind of questions can be asked from here? The first type of question is, what is the DFS sequence you had? DFS is this one. This one, A, B, E, C, D, F. Now you tell me, what are the nodes you have not pushed onto the stack? What are the vertices you have not pushed onto the vertex? You have not pushed onto the stack. Vertices not pushed onto the stack. Can you name those? Yes, you can. Those are C and F. Yes, C and F both you have not pushed. A, B, E, D you have pushed, but C and F not pushed. One more type of question can be asked. This is first type. This is second type. Another question, and that question is, what are the vertices you have pushed onto the stack more than once? Vertices pushed more than once. Can you tell me? Only one, which is E. Which is E. Hope you understood this. सबको समझ में आया है? I need acknowledgement. Why? Just because if you understood this method, then based on this method, one more question we are going to solve, and in that question you will take a lead. You will become my leader and you will solve the question and you will tell me that this is the way to solve this question, sir. हमको पता है, हमने सीख लिया है. गुड. हर्ष शर्मा सेज, अरे सर हमने तो आपको सीओए पढ़ाते हुए देखा है, अब बस डीएस भी गजब ही. आप पूरा प्लेलिस्ट देखें, आपको बहुत मजा आने वाला है हर्ष. यू विल लर्न अ लॉट. चलिए, अगर अंडरस्टूड, नाउ यू आर गोइंग टू टेक द लीड. टेक योर पेन पेपर आउट एंड लेट्स सॉल्व दिस पर्टिकुलर क्वेश्चन अलोंग विद मी. नाउ लिसन, one thing which is very necessary for you. Listen this. If I say from here, if I ask how many neighbors of A, you say B and C from the graph. Understood? Yes. Which will you traverse first, B or C? You can traverse anyone. Just because graph is given, I don't know which one is the first node or first neighbor and which one is the second neighbor. मुझे नहीं पता कौन सा नेबर फर्स्ट है, कौन सा सेकेंड. अभी ये देखो, if such kind of representation is given, if I ask how many neighbors of 1, you say 2. Which one is the first neighbor? Which one is the first neighbor? 2. Means first of all you need to take care of 2 and after that you need to take care of 3. If such kind of representation is given, then you need to take care of the sequence of the vertices, sequence of the neighbors. If I want to start from 2, I should take care of 1 first, then 4, then 5. I can't from 2, I can't directly go to the 4 until I process 1. Understanding that? Understanding that? समझ में आ रही है ये बात आप सब लोगों को? Everybody here, everybody. चलिए तो अब क्वेश्चन सॉल्व करते हैं. ऑल दीज थ्री क्वेश्चंस व्हिच आई हैव रिटन हियर इन द ग्रीन कलर, I will try to give the answer based on this question. Perform the DFS on the given graph with source vertex 1. Let's do that. Let us do that. So let me first draw a stack here. Fine. Now let's start. Vertex 1. So we have called DFS function for 1. So very easily I can say DFS of 1 means DFS 1 is traversed, marked as visited. Now I am processing. Processing means executing DFS function for 1. Executing the DFS function for which one? 1. I'm trying to find the first neighbor of 1 which is not yet visited. The first neighbor of 1 is 2. Not yet visited? Yes, not yet visited. Should I call for 2? Yes. I should call for 2. So I have called for 2. When I have called for 2, then I will push 1 onto the stack so that I can return back to 1. Then I will call for 2. When I will call for 2, 2 will be marked as visited. Yes. Explode. Traversal sequence 2. Now I will try to execute DFS function for 2. Let's try to find out the neighbor of 2. Neighbors of 2. The first neighbor of 2 is 1. Visited. Fine. Then next neighbor is 4. So once I have assured that 1 is traversed, then only I am going on the second neighbor which is 4. 4 is traversed? No. So let's call for 4. Let us call for 4. When I am calling for 4, 2 will be pushed onto the stack as return address or return function. Let's call for 4. Visited, traversed in that sequence, and now I am executing DFS for 4. For 4, when you will call the DFS, first of all you will find out the first neighbor is 2. Visited, 8, not yet visited. Let's call DFS for 8. Let us call DFS for 8. We have called DFS for 8, which means you will have to push 4 onto the stack and then call for 8. Visited, traversed, execute the DFS for 8 now. Let's try to find out neighbors of 8. First neighbor is 4. Already visited. Next neighbor is 5, not yet visited. Call for 5 means 8 will go onto the stack. 5 will be visited means I am executing DFS function for 5, marked as visited, printed, and now try to find the neighbor of 5. 5 ka neighbor 2, already done. 8 already done. So means there is no any neighbor of 5. We will not be calling anything else from 5. No. Go back. Go back means from here we will go back to 8. 8 will be popped out from here and we will execute again 8. For 8 we have already checked 4 and 5. Now we will check 6. Is there any neighbor of 6 which is not yet visited? Yes. So go for 6. Call for 6 means 8 will be pushed onto the stack once again. Call for 6. 6 will be visited. I am executing now the DFS function for 6. Let's go for 6. What is the neighbor of 6? First one, 3. 3. 3 is not yet visited. Yes. Call for 3. If you will call for 3, then 6 will go onto the stack. And you will call for 3. Visited. And then we will be executing DFS function for 3. Is there a neighbor of 3? Yes, 1 already visited, 6 already visited, 7 not yet visited. Call for 7. The DFS function means 3 will go onto the stack and 7 will be called. So you'll be executing 7 DFS function. It's visited. Traversal sequence will have 7, and now we will try to find out the neighbor of 7. 3 already done. 8 already done. Go back now. There is no any function call from 7. Go back now. Go back to 3. Is there a neighbor of 3 remaining? No. सबके सब traverse हो चुके हैं. Everything is traversed. Yes, everything is traversed, then go back to 6, then go back to 8, then go back to 4, then go back to 2, then go back to 1, and done. So this is the traversal sequence: 1, 2, 4, 8, 5, 6, 3, 7. Vertex which are not pushed onto the stack. 1, 2, 3, 4, 5 is not pushed onto the stack, and 5 and 7 not pushed onto the stack. More than once pushed onto the stack, 8. So these are the answers for this question. Superb, 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 amazing, 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 amazing. If anybody need any kind of notes which we are taking classes here for, then go to a particular Telegram channel here. On this channel, you will get all the lecture notes which we are taking here. If you are taking any class on this Unacademy Computer Science YouTube channel, you can get all the lecture notes of every lecture there. चलो वापस से जाते हैं इस क्वेश्चन पे. If you understood this, then we have look at this. Okay, solution के लिए मैंने जगह वहां कर दी है already. We have a GPK for you guys. That is घर पे करो problem. It's a homework question. In this, you need to start from vertex 7, same graph, and another homework question which have been given to you. You need to start from vertex 8. Solve these two questions. You will definitely understand the question. How exactly this particular implementation is done. If you still need help, you can watch these two examples. Definitely you will understand how to do that. Fine. चलिए वापस अब इस क्वेश्चन पे जाते हैं. Let's go back to this particular question and let's try to solve what exactly they are trying to say. First of all, we will try to understand the question. After that, we will try to understand how to approach. It's a GATE Computer Science 2014 question. Suppose DFS is executing on the graph below, starting as some unknown vertex. Vertex source is not known. From anywhere you want, you can start. Assume that a recursive call to visit a vertex is made only after first checking that the vertex has not been visited earlier. So means for the node, if you are calling the DFS function recursively, then you are first assuring that for that node only you call the DFS recursively which has not yet traversed. जिनका traversal नहीं हुआ है उनके लिए ही कॉल करें, उनके लिए ही कॉल करें, right? Then the maximum possible recursion depth including the initial call is. You don't know what is recursion depth? No problem. I will explain you. Look at this. Let me go back to this example. In this example, if I would like to check out that what is the maximum possible recursion depth, what is the meaning of recursion depth? Look at this example. From A, first of all, I have called recursive call or DFS function call for A, which is first call. From A, I have called B, then depth becomes 2. Then from B, I have called for E, depth becomes 3. From E, I have called C, depth becomes 4. But from C, I am not calling anything, I am coming back to E. Means recursion depth decreases to again 3. Now from E, recursively you are calling for D, recursion depth 5. Ki 4. 5 ki 4. 4. Why? A, B, C, E, 1, 2, 3, then 4, then coming back to E means recursion depth has reduced to 3 now. Now from E to D, recursion depth increased to 4. Then from D to F, you are calling recursion depth increases one more 5. So in this example, I can say recursion depth is 5. Can we have 6? Yes, in this question we have 6 also. How? For first of all, you call for A, then C, 2, then C to E, 3, E to B, 4, B to D, 5, D to F, 6. So what is the Maximum possible recursion depth in this, when I'm starting from A, answer is 6. Exactly same thing I'll have to do for this one. What is the maximum possible recursion depth if you start from any vertex you want to for the DFS execution? चलिए करते हैं. Let's do that. So I have drawn this and I would like to solve this question along with one example. What I will do, I will give the number or labeling to each and every vertex. So vertex, this is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, N, then O, P, Q, R, S, T, and U. These are the vertices. See, there are multiple solutions. One of them I will tell you. I will go in this particular way. First of all, I will start from A, it's a source. B, then C ka call, then neighbor F, then E, then D, then G, H, I, J, then K. But from K, I'll have to go back. L, M, N, Q to R, come back from here, then P, O, S, T, and U. Like this way you can go. Okay, so let me just write down the recursion sequence. I will write down. First of all, you have called for A, then from A you have called for B, then B says C. Let me write it in horizontal manner. A to B, B to C, C to F, F to E, E to D, D to G, to H, to I, to J, to K. But after K, there is nothing, neighbor of K, nothing. So you come back to J, and from J you are calling for L. Then from L you are calling for M, then N, then Q, then from there R. But there is no any neighbor of R, come back to Q. From Q you are calling for P, then O, then S, then T, then U. Let's check it out. What is the recursion depth? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So up to K, the recursion depth is 11. Come back to J, which is 10. 11, 12, 13, 14, and 15. Up to R, we have 15. Come back to here, 14, 15, 16, 17, 18, and 19. Maximum depth we can have is 19. Yes, Pratap, really good. Really good. 19. Vishvadeep, really good. 19 is the correct answer. That is a gate question. So now this particular question is more of a puzzle kind of question. They have just merged it into graph data structure, nothing else. We have one more modified version of the same question. We have one more modified version of the same question. Look at this. Look at this. So answer for this question is 19. I have brought a modified version of the same question. Suppose the first depth first search is executed, same to same thing. The maximum possible recursion depth in best case, including the initial call. Now the question is best case. Best case means we would like to keep the depth as minimum as possible. We would like to keep depth as minimum as possible. Means if suppose I am saying that my answer is 12 or 13, then within 12 recursion depth, all the nodes should be traversed. All the nodes should be traversed. All the nodes should be traversed. सारी की सारी node traverse भी हो जाए और minimum depth I will achieve. Minimum means minimum in such a way that more than that depth I will not get to traverse entire graph. That is another puzzle question which I have created here for you guys. What should be the answer? Can you provide an answer for you? Can you provide an answer for this one? Can you provide an answer for this one? Can you provide an answer for this one? Okay, check. So let me help you guys. I will do the same thing. I will give the numbering or labeling to each and every node here too. D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. That is the labeling. Okay. So we have two answers which are saying 11. Let me start with my answer. So first of all, if I want to minimize the depth call, or if I want to minimize the recursion depth, I will try to divide the entire call in multiple sections. Like from one node you start, one side you go, you traverse some nodes, come back here only, then other side you go and traverse some nodes, come back here only. Like this way I'll do, so that in one particular sequence, I will not be traversing all the nodes. And the best way to do is start the traversing from this middle node J. Yahan se. This middle node J. Right? So I am starting my traversal from J. From J, I am first calling for K. Is there any neighbor of K? No. Then come back. Means up to K, you have achieved the depth 2. And then came back to J. Now, go back to J. Now from J, I am going towards left and right. Once I will go towards left, all these 9 nodes I will traverse, come back to J, and then these 9-10 nodes I will traverse and come back to J, so that I will be having less depth. Now, can I divide these nodes also? Yes. How? If you will cut this particular graph either from middle vertically or from middle horizontally. नहीं समझ में आया? Okay, I will tell you. Let's see. I am cutting this particular graph horizontally. Means from J, I am calling for I. From I will traverse this entire middle row first. F, then E, then D. Now see, from D you have two choices. Either go up or down. If you go up, you will have to come back to D to traverse the downside nodes. So you are going from D, suppose above. A, B and C. From C, F is done, go back. D, B, C, E is already done, go back. A, D, well, you will go back to D, and then from D you will go down, which is G and H. From H, I already done, yes, so go back and come back here to J. This much was the maximum depth one side. Now go for the other side. From J, again go for the next other side. From J, I am doing the same thing here. L. From L, I am going to cut this graph from middle like this. O, P, Q and R. From R, go back to Q. From Q, I am going up, which is U, T and S. Go back to Q. From Q, you will have to come down, which is N and then M. All the nodes done? Yes. What is the depth I am achieving? 1, 2, 3, 4, 5, 6, 7. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 6, 7, 8. 6 and 7. Now in the best case, what is the maximum? What is the maximum in the best case? Answer is, just check out यार, अब तो सामने से लिख दिया है सब कुछ मैंने. I have written everything here in the front. Everything is written. What is the maximum in the best case? Answer is 8. This is another puzzle. So if you have seen my lectures previously, on the last Sunday I have given you a particular tips and tricks lecture. In that I have mentioned that if you want to improve your problem solving by just looking at the question, then you need to start solving the puzzle. If you are targeting the gate exam for any high level rank, then you should have a really great problem solving, and all the gate questions are kind of puzzles only. So always remember, if you have practice of solving the puzzles or good mathematics question or good aptitude question, then definitely gate exam will be little bit easier for all of you. Fine. Okay, so one last thing remaining in today's lecture, which is complexity. What is the complexity of the operation of the BFS and DFS? Now it is totally dependent on how and why you are implementing the graph. How you are implementing the graph. There are two ways. Yesterday we have talked about that in mostly two ways basically you can implement the graph. One way is if you are implementing the graph in adjacency matrix. Second way is linked representation or list representation. If you are implementing the graph, in the adjacency matrix representation, then in that case the number of edges information will be n square for n number of vertices. Then in that case the complexity of BFS and DFS becomes big O of n square. Simple, sure shot. For each and every node you need to have entire row traversed, n, then n, then n, then n, then n, so that you can perform the operation on the edges. That's why n square. But if you have the linked representation, if you have stored the edges information in the linked, then you are not storing those edge information also which is not present. If you have not learned that linked representation and all, linked or hybrid representation, then please go for it. In that particular case, the complexity will be big O of number of vertices plus number of edges. V is what here? V is number of vertices in the graph. And what is E? E is number of edges. So I can make these two also like this way, big O of V square. And DFS also same to same complexity, V plus E. Why so? Why so? Just because here we have those many operations only which are the edges present for each and every vertex. That's why total vertex suppose V, then V operation for each and every vertex. Apart from that, for edges, how many operations you will be performing, how many edges you are having, those many operations you are performing. That's why V plus E. So remember, it depends, the graph complexity or the BFS DFS complexity depends on that how you are representing your graph. If you are representing the graph in adjacency matrix or table, then V square, that is the number of vertices square. If you are representing in linked, then V plus E. Now V plus E also can be V square when you have a complete graph. What is complete graph? Each and every vertex is connected to each and every node. Each and every vertex connected or having edge to each and every what? Other vertex. That is complete graph. In complete graph, you will be having V square number of edges, and hence in that case you will be having this much, but not always. That's the worst case. Got it? Chali. Okay, what's next? Now next thing are remaining hashing. Hashing, collision, and some more questions we will be solving from hashing and graph, and then we will be done with this particular course. If you guys are waiting for gate 22 23, I already told you, one more time I'm telling you that we are having this particular special series of lectures for you, absolutely free special classes on Unacademy's platform. If you haven't created the Unacademy's account, create it for free, and of course use this particular code VDEEP10 to unlock your free content. What you will be getting in these special classes, you will be getting a complete roadmap to approach each subject. So for one subject, one class of 1 hour will be conducted, so that you can understand how you will approach that particular subject, how much weightage of that subject is, what are the important topics, how or what sequence you should apply, or you should learn in what sequence, so that you can learn the course in the perfect manner. For this one, you need to go to this particular channel. On this channel we have dropped the link and entire detail about this particular lecture series, and the link also of the lecture series, so that you can understand and you can know that at what time, at what day, which particular subject, and who, what, or which educator will be taking that particular subject detail analysis. For heap, we already having heap data structure being covered in the morning session, which is conducted on 10 a.m. 10 a.m. algorithm ka course already going on. In that, one of my fellow educator Ankush Saklecha sir is taking DA course, in which he is discussing heap only. Just check out that particular lecture. If you still find some problem or query, you can definitely ask me for the same. This is a complete package we are providing here. You can just check out in your playlist. In this particular channel's playlist, check out COA ka playlist, discrete math, theory of computation. This is my team. 3 more members apart from this particular visible members we have in my team, and this particular team is working hard for you, providing quality education on the YouTube, on Unacademy, on Unacademy Plus also. If you want to join Unacademy Plus, don't waste your single day. Start preparation as soon as possible, so that you can remember all 12 subjects in the exam properly. Otherwise you will struggle a lot if you will wait अरे हो जाएगा and कर जाएगा वाला attitude if you will carry forward with. Remember the code VDEEP10 so that you can get the 10% discount, and you can connect your preparation with my team's effort. If you want to be connected with us, there is another opportunity on Facebook. You can be connected with us on Facebook also. If you have friends in other branches like electrical, mechanical, civil and all, you can recommend them our family channel. Family channel means मेरी अरे मेरी फैमिली वाला चैनल नहीं है, हमारे एजुकेटर्स फैमिली का चैनल है. इलेक्ट्रिकल ECIN के लिए वी हैव क्रिएट्रिक्स चैनल, विच इज वन ऑफ द लार्जेस्ट प्लेटफॉर्म for electrical ECIN to learn in India. We have this particular channel lead by Mr. Devendra Negi. He is one of the best educator, and he is having a team of really great educators, top educators of country for mechanical, PI and XE. We have for civil Abhishek Kumar sir and his team. For you guys, recommend your friends these channel. SSC, JE, RRB, computer science. For computer science we have your own channel. This particular channel already having lot for you. Go and check it out. If you haven't subscribed the channel, please do it. If you haven't turn on notification, do it. If you haven't liked the video, every time you watch the video, like it, share the playlist, video and the channel too. Okay, there is a question, sir. Love the COA lecture. Thank you so much, Aditya. Can you please drop a comment on the first video of the lecture? It will be a really great help for those students who want to take a decision to watch that playlist, but they don't know if the playlist contains everything or not. Link list I want to learn, Harsh Sharma. You can just check out this particular channel. Under the channel I have and already covered entire link list in much needed detail. Check out some questions, lots of practice questions also all I have solved on link list chapter. Go to playlist section. Unacademy Computer Science is the channel name. Go to the playlist section. In the playlist you will find out data structure. In that you will find out the link list. Thank you so much for joining here. Next session 8:15 soon going to start. Don't forget to join that TOC crash course. Happy learning. We will see you soon. Till then, have a nice remaining day. Bye bye.